Hello everyone, my name is Anamika and welcome you all to the Basic Teacher, a platform dedicated to making learning simple, effective and enjoyable. Okay, so today we are going to discuss about Apache Airflow in detail with hands-on, and we will see into an understanding with real-time project that how we use it, how we create the DAGs, how we schedule, monitor and going through the logs. Okay, before continuing that, we'll walk you through about this slide where I have listed some trainings. If you are interested with any, just drop an email to official.thebasicteacher@gmail.com. We will be back to you with your points you have mentioned in the email. Okay, so let's continue. Here, it is a official website of Apache Airflow. Here you can see the clear definition of it, that Apache Airflow is a platform created by the community to programmatically author, schedule, and monitor the workflow. Okay, here is the option for installing Airflow. If you do not have the setup, simply you can install, and then once installation is done, you can create your own DAG, schedule, monitor, and all. Okay, let's move next. Here we talk about principles. So it is having the options like scalable, dynamic, and extensible, elegant. So here scalable in the sense Apache Airflow has a modular architecture and uses a message queue to orchestrate an arbitrary number of workers. Airflow is ready to scale to infinity. And dynamic one, these pipelines are defined in Python, allowing for dynamic pipeline generation. And this allows for writing code that instantiate pipelines dynamically. For extensible, easily define your own operators and extend libraries to fit the level of orchestration and abstraction that suits to your environment. Apache Airflow pipelines are lean and explicit parameterization and built into its core using the powerful Jinja template engine, and that is making it really very flexible and compatible. If we talk about its feature, then we have pure Python and UI. So no more command line or XML black magics, just use pure Python, standard Python, and start with your development by creating the DAGs, scheduling, and all. Using the UI, you can monitor, schedule, and manage your workflow via a robust and modern web application. Okay. Next, it is having robust integration where you can integrate with several tasks on Google Cloud Platform, Amazon Web Services, Azure, and any other tools like this, including many other third-party services. And this makes Airflow easy to apply to current infrastructure and extend to next-gen technologies. And the major thing is, this is really very, very easy to use. So anyone with Python knowledge can deploy a workflow. This Apache Airflow does not limit the scope of your pipelines. You can use it to build ML, models, transfer data, manage your infrastructure, and many more things. Okay, and this is open source. So if you have anything to share or you want any improvement, just open the PR and it's done. It will be taken care by the team. Okay, then a major part is the integration. It allows you integration with JDBC and Hadoop. Including this, you have option for Google Cloud Vision, you have Microsoft Azure Bench, then you have Google Cloud Text to Speech, Google Cloud Stack Driver, and Google Analytics 360, Apache Druid, and many more. This is not the limit. Many more services are there where you can do the integration and you can work with it. Okay, so next go to the detail how it works and then we will go through the coding part. Here, let's try to understand about Apache Airflow. So Apache Airflow is an open source platform designed for programmatically authoring, scheduling, and monitoring airflows, and it allows developers To create directed acyclic graph to define the workflows, ensuring that the tasks are executed in the correct order with the required dependencies. Okay. Now, dynamic workflow, task scheduling, scalability, extensibility, and monitoring and loggings are some key features of it. If we talk about workflow, then workflows are defined as Python code, making them dynamic and easy to configure. For task scheduling, Airflow supports scheduling tasks based on the time intervals for specific conditions using cron expressions, where if you want to schedule the job independent or dependent or with the time or with the dependency of the file or dependency with particular time that this should run after 12 p.m. only or this should run after this file is available only. Like this, you can have multiple options. You can schedule. Scalability with its modular architecture, Airflow can scale seamlessly to handle large workflows. And Airflow provides operators to interact with external systems like database, cloud storage, and other APIs. And it is good to do the monitoring and logging as it is having a web-based UI where we can do monitoring and troubleshoot the running DAGs and tasks as per our requirement. Okay, so now we can say how airflow works actually. So it is having these terms to work. First is that directed acyclic graph, where we create a DAG, which is a collection of tasks with defined dependencies and ensures tasks are executed in a specified order without cycles. Okay, now tasks. The basic unit of execution in a DAG and can perform various operations like running Python code, executing SQL, or transferring the files. Then the scheduler part, which determines when tasks are ready to run based on their schedule and dependencies. And the executor. So manage task execution either locally or on a distributed cluster or on a cloud environment. Metadata database where it stores information about DAGs, task states, and history. So all the details will be captured in the metadata database that can be accessed as per the requirement. And then web interface. It provides visibility into the status of workflow and allow users to trigger or stop the jobs. Now, the main thing is what is the use case of Airflow? So we have many use cases, including ETL, where we can perform our extract, transform, and load operations with its workflow, and data pipeline orchestration, machine learning pipeline automation, managing CI/CD pipelines, and reporting and monitoring systems. Okay, what is the advantage? So in advantage, you can include these points like code edge configuration. That means workflow are written in Python, allowing for flexibility and reusability. Extensive community support, so backed by a large community, ensuring regular updates and plugins. So there will not be anything that this doesn't support. If something new in the market, if something is getting updated, then Airflow will also getting updated to enhance itself, and it will always make sure that its integration is perfect with another services with it already connected, it's already working, or maybe any new services are getting launched, then for that also it is good to integrate. So because this is supporting many more platforms, many more services, and again, this will be continuing to do so with some additional services in future. So, and it is having capability to work well with many tools like Hadoop, Spark, Hive, cloud platforms, AWS, Azure, GCP, and many more. Okay, so this is having limitations also. We say no, nothing is perfect. Everyone is having some good things, some bad things, some pros, some cons. So this is also having some cons. So this is having the limitations. Like may have a steep learning curve for beginners. Performance can degrade with extremely large DAGs if not optimized properly and requires careful configuration for high availability. Okay. Now, why we use Airflow? So Airflow is ideal for organizations looking to automate, scale, and manage complex workflows, and it integrates well with a variety of ecosystems, making it a powerful tool for modern any of the engineering core, either it is data engineering, data science, or your web application, some other software development, many more. We can't say that this is having a limit. Okay. Now let's start with its coding part. So first you have to make sure that you have Apache Airflow setup where you can do your POC and you can try out. If you do not have the setup, then you can go here. You have seen already that it is having an option for install Airflow. You can click here and you can install it, or you can do it like this as well. You can do pip install Apache Airflow, and then you can do with all this setup. And once you are done, then you can start exploring it with your local setup. Okay, so as of now, I have already set up, so I am not going to go through this installation. But if you are looking for this, you can drop me a message. I will create one video for that installation and all the setups where you can run your jobs. You can create the DAGs, you can schedule, and you can do the POCs locally. Okay, so here I will go through the coding part. How you, let's assume that you have Airflow setup locally. You have already installed and you have set up. Now how you will be creating the first DAG for the application. So here I am just trying to create a DAG. I have mentioned this code on this page, but I will go through the PyCharm where I have created classes for it. So this is for import, basic import I have imported, and this is the default args which is optional, either you can provide or not, but better if you provide it. Then creating the tag. So these are just the option. Creating the tag where you have to provide the tag name, then default args. This is the default arg, and then description. If you have any description for your job, then schedule interval. This can be anything like daily, monthly, weekly, anything. Then start date. When is the start date for this job? And catch up. What is catch up? We will discuss in this document itself after some point. Okay. Then define the task. You have to uh, configure that which task you are going to schedule. So let's assume that you are having this task, you have a function print hello, and this is the part of this function. Now you want to schedule it. So you are having task one, like that you can have multiple tasks, task one, task two, task three. So this is just for example, for your understanding, where you are giving Python operator, then task ID, you can give anything task ID, and then Python callable, and you are giving this function name print hello. This is the print hello. So this function you are calling here, that's it. Your DAG is done. Now this task you can call to run. This is here you are calling, and now it will be running. So what you did total? First you did import, where you imported the DAG, the Python operator, and then date type, which you need for this DAG preparation. Once this import is done, then you created default args, where you provided the default arguments with owner, email, retries, and other details. Then once your default args is done, then you are creating a tag where you are providing all the details that this is the first tag, then default args, then description, scheduling interval, and all. Once that is also done, then you are coming to your application where either you are creating your function here itself, or maybe you are importing it from other class file, and that function you are calling to the task. This is the task one, and inside task one you are calling your function, and then you are running. This is the scheduler. Here you are calling your task to run. That's it. Your diagram is done. Okay. So this was very simple tag. Now you can have some complex DAG also, complex pipeline also. Like, let's take example for ETL example, extract data, transform, and then load. So If you are doing all these things, then of course our code will be a bit complex. So here I have taken import pandas IHPD with pandas framework we are going to work. And then importing the DAG, Python operator and time delta. Here you see I have given the default args where owner equal to Anamika, dependent on past, false, email on failure, false. If you want to make true, then do that. Email on retry, false, retry, I am giving only one, and retry delay. If you want to give some buffer time, you can have it. Then I am going through extract, transform, and load. So let's assume that these are the three functions. This is doing the extract, this is doing the transform, and this is doing the load. So for extract, what you are doing? This is the manual data. This is just a POC. So I have given the manual data and all, but you can have your own actual data. So let's see, created the manual data and then using the pandas data frame, converting to CSV. Okay, it's done. Then transformation. Reading that CSV that we already created here, data.csv, and then doing some transformation and again saving to the location. And finally loading the data. So read the CSV and print print data frame. That's it, your task is done. Now creating the tag. So in this tag again, ETL pipeline, then default args, then example ETL pipeline, then time delta, whatever details you want to provide, catch up, false, catch up. What is catch up? We will discuss that in the same. Now you have to create the task. So this is the DAG where we have three tasks. So first I am creating the extract task, then transform task, and then load task. So we'll create three tasks and all three tasks should run. This one. So three tasks is created, and then you can see in extract task I am giving extract and Python. This is the callable. This is the function name. Okay, like that. Here I am calling the load function and then extract, transform, and load. So all are in the sequence. This is the extract, this is transform, and then this is load function. Finally, our all three tasks are created. Then we are going to call all three tasks, extract task. Then first it should complete. It is having dependency. If we are marking this arrow mark greater than, then this is for the dependency. So first this will run, then this will run, and once this is also completed, then this will run. This will run in sequence and not parallel. Okay. Now, you can have a requirement where you are looking for some sensors and external triggers. Like, let's assume that your job should run only a special file should be available to the specific location. That means it should wait for the file. Once file is available, then only job should trigger. So you can set up that. You have the option file sensor. Using file sensor, let's say task ID equal to wait for file. So it will wait for file. Which file? This file means this path and this file name. So it will wait until unless file is not available, your trigger will not work. Once file is available, then only job will be triggering. Then perk interval 5, timeout 300 and a tag. So like this, you can have a dependency over the file and you can define it with file sensor. And like that, you can have multiple other options as well. Anyways, let's coming to next. In above task, extract, transform and load, you see that was running in sequence. Okay. Now here we can create a tag which will be running in sequence and in parallel both. Okay, so now this is the tag, this is the import, and in this import, this is the default args. And after this default args, task A and task B and task C. You have three tasks. Then creating the tag. In tag, you are giving sequential task, then default args. This job will run on daily basis. This is the start date time, and this is the catch up false. Now come next. And now for each function, we have to create the task. So task one. Task one is calling task A. Then task two. Task 2 is calling task B, and then task 3. Task 3 is calling task C, like that. Okay. Then define dependencies. This is running in sequence and not parallel. These are the dependent. Now, if you want to run this in parallel, then you have not to do anything else. All the steps will be almost same, like creating the DAG, then creating the task, and then finally schedule. So finally schedule, you can just give it like that. And now it will be running in parallel and not in sequence. There will not be any dependency. Okay. Now, in the same job, you can combine sequential and parallel both. So let's say this is your DAG is done. Then you have task 1, task 2, task 3. This is also done. Task 4, you done with this as well. Now let's run this. Task 1, then you can see this symbol, then task 2 and task 3 with comma separator, and then task 4. In this case, first task 1 will run, then task 2 and 3 will run in parallel. And again, task 4 will be running once previous jobs are done. These are the dependencies. Okay, so like that, in the same job, you can have either a complete sequential or complete parallel or combination of both, where some of the jobs will be running in parallel and some of the job will be running in sequence. Okay, now predefined schedules. If you want to schedule the job, then you have some predefined things like once. Once means runs the DAG only once. Hourly runs once every hour. Then daily runs once a day, midnight UTC by default. If you want to schedule with your IST or any other time zone, then calculate the time properly and then provide the time accordingly. Then weekly runs 1 a week and monthly runs 1 a month and yearly or annually runs 1 in a year, and that will be running midnight UTC on the January 1. Now cron expression to give the time format. Like if you want to schedule with some time specific, like some day, hour, minute, second, month, and all. Then how you can. So here is the format of minute, then hour, and then day of month, and then month, and then day of week. Like that is the format. So here, if you are giving 0, 6, and 3 star, that means this job will run every day at 6 a.m. If you are giving 15, 14, 1, and 00, that means this will be running 2, 15, 2 means this 14. 14 means hour. Here you can see hour. Second parameter is hour. Okay. And here second parameter. So 14. 14 means 2 p.m. So this will be running at 2 p.m. Then 15. 15 means what is the first parameter? First parameter is the minute. That means 15 minutes. So it will be running over 14, 2 p.m. and 15 minutes on the first of every month. This is the month. Okay. So this is third parameter is day of month. So this is the first day. Like that, this will be scheduled. So say this one 09 double star 1, that means every Monday. Okay. Last you can see this is the month and this is the day of week. Day of week means this is 1. 1 means Monday. So every Monday at 9 a.m. this job will run. Here you can say /2. That means every 2 hours. Your job will be running every 2 hours. And this one 0, 9 to 18 and then /3. That means your job will be running every 3 hours between 9 a.m. to 6 p.m. 18 means 6 p.m. evening IST. Okay. So here just I am talking about IST, it means 18 and 6, but the default time zone is the UTC. If you are doing the schedule, then make sure that it is running as per requirement and you are meeting with the criteria and it is good, because maybe you are thinking that you are running with the 6 p.m. IST, and you schedule with that, and this is not running actually at the 6 p.m. because that 6 p.m. it is considering with UTC. Okay, so make sure that you are doing the calculation properly and then work accordingly. Okay, so then some special cases are there, like if you want to run your job a weekend, weekdays only, or weekends only, or first month of the day, or end month of the day, then you can schedule with like weekdays only. So 0 to 9, that means 9 a.m. and 1 to 5. 1 to 5 means Monday to Friday. It should run, means it will be running over the weekdays and not the weekends. Then first Monday of the month. First Monday of the month, 0 to 9 means 9 days, and 1 to 7, and then 1. So this will be running over the first Monday. Like that, you can have the schedule. Now, catch up and backfill. This catch up and backfill, here you have seen in the DAG. I am coming to DAG. Whenever you are defining the DAG, there you have option catch up. Catch up equal to false. So what is catch up? Catch up and backfill. So catch up. If a DAG starts late, Airflow will miss the schedule. For example, if job is starting, means for any other job start date is January 1 and today is January 5th. Just I'm taking the example mentioned here. Then Airflow will run the task for January 1 to 4 if you have enabled it. And then it will be running for the current date. So if there is any issue with the scheduler, it will not be missing any of the run, that will complete. And disable catch-up. Add catch-up equal to false in the DAG. That means that will run for only the current date and it will not care about if any missed schedule or something else. So if you are making true, then it will take care. For any missed schedule, that will run first before starting the current one. And if you are making that false, then it will not care about that. It will run only for the current date. Okay. Then you have option for catch up, where this ensures if a DAG is behind schedule due to a late start or other reasons, and it will automatically execute all the missed schedule to catch up. Okay, so what is the behavior of it? So if a DAG is scheduled to run daily and start late, Airflow identifies the missed schedules and run tasks for those intervals in sequence until it reaches the current date. Okay. Here you can see the example. If a DAG has a start date of January 1 with the daily schedule, and if it first trigger January 5, then Airflow will run all the tasks for January 1, 2, 3, and 4 before running the current one. So there will not be any loss. Then disabling catch-up. If we disable catch-up, then it will not care for anything. It will just run for the current date. Okay. How you can use it? Whenever you are creating the DAG, there itself, you have to either enable or disable it by providing true or false. Okay. Then when to use catch-up? When you have the requirement for backfilling historical data, then yes, you do not want to miss anything. You want to process all the data, then go with it. Then go with it. And when you want to ensure every scheduled interval is processed, even if the DAG starts late, then this is useful. And then disable catch-up. For the real-time pipelines, where only the latest schedule matters, you are not caring about if any missed schedule or yesterday did not run, then what happened? No need to worry. Whatever is coming today, just run that. If that is the case, you can disable the catch-up. And to avoid processing a backlog of tasks, both the conditions are there, then you can. Then we have sensors. As I said, we have file sensors where we can have a dependency that if this file is available, then only we will trigger the job. So in that case, we have multiple sensors provided in the Airflow. You can set up any as per the requirement. So here sensors are special types of operators used to wait for a certain condition to be met before executing downstream task. And they seen or listen for specific events or a condition such as the presence of a file, a specific time, or the successful completion of an external task. Okay, so in the list you have time sensor. Time sensor means time based and it will wait until a specific time of the day. Okay, what it will do? So first you have to import this time sensor and then import the tag and that time. Then when you are creating the tag, that time you can give your this is the tag ID just for your understanding. You can give anything and then start date, then schedules daily. This job will run daily. Catch up equal to false and wait for time sensor. Task ID, wait for a specific time. So target time you are giving 12. That means it will wait until noon. And before that, job will not trigger. This is dependent that this says to wait for this time to be. And once that time is okay, then only your job will trigger. Next, you have file sensor. File sensor is file based. Okay. So file sensor is file based where it will wait for the presence of a file to the specific location until unless file is not available, the job will not get triggered. So file sensor in Apache Airflow is an operator used to monitor the existence of a specific file at a given location and it pauses the execution of a task until the specified file is found and it enables workflows to depend on external files or data availability. So what is the key feature of that? One is monitor file availability. So it checks for the presence of a file at a specific path and blocking the behavior. So task remains in the running state until the file is found or the sensor timeout. Polling interval, the frequency at which the sensor checks for the file and then timeout setting. If maximum time of the sensor is filled, then let's say you have set up some time. So if maximum time is over, then sensor will wait before failing. Okay, so it will be checking first monitor file availability. First, it will checking if on that specific path file is available or not, and the task will remain running until sensor time is out. And for the polling interval, frequency at which sensor checks for the file, it will go and it will check back if file is available or not. And then maximum time the sensor will wait before the failing. If you have provided a timeout setting and if that is over, it will start failing. Okay, how you can set up that? First, you are doing the import, then you are creating the defaulters, and with this defaulters, you are going for, let's say, DAG ID for understanding purpose, you are giving file sensor example. Then you are giving all the details like defaulters, daily, and date time, false, and all. Then file sensor to check a file in the local system. So here you can see file sensor, check file exist. It will be going and checking this path if file is exist or not. And interval is let's assume 30 minutes. So time between the checks, it will be going and it will be checking either that file is available or not. And then timeout before filling the task. Whatever timeout you have provided, once this is over, then it will start the filling. And then mode poke. Poke means reschedule. Okay. Then here mode is poke means either this will be rescheduled or this will be poke by default. Okay. Then you are having SFTP sensor. SFTP sensor is also there where it will be monitoring for that SFTP. It will making sure that file is available with the same like file sensor, and once that is available, then only it will be started running. Okay. Then you have the choice that when to use file sensor and when not to use it. Okay. Okay. Then when to use file sensor. So to ensure that workflow proceeds only if necessary input files are available. There can be some dependencies sometimes. Without that file, you can't process because that's the main input, or maybe it is having some necessary input data. So in that case, we have to wait. So if that is the requirement, then for external systems that generate file on a schedule or with SFTP, FTP servers or local batch jobs, or to synchronize with the upstream data pipeline. So if that is the case, then we can go for file sensor. And we have to follow some best practices as well when you are trying to use it. Otherwise, you may face some challenges. So in best practices, you can see about avoid long polling intervals. So use appropriate poke intervals and timeout settings to prevent unnecessary resource consumption. Then prefer reschedule mode. So free up worker slots and is more efficient in resource constant environments, and combined with dependency checking, where you can ensure upstream process that generates files are well defined. Then S3 case key sensor, where your type is cloud storage and description waits for a file, that means key, to appear in an S3 bucket. So all this can be your considerations while you are working with it. And if you want to set up, then how you can import this and then go with the tag. In tag, you have to provide all the details, and then either you are going for time sensor or file sensor or S3 key sensor, you can provide that details here. Okay, once that is done, then you are all set. Then you have one more option, external task sensor. External task sensor, that means you have another tag, and your current tag should run once that another tag is done, that is already processed. So there is a dependency between the tags, that one job should be completed before running this. So with that dependency, this is task based and description is to wait for a task in another tag to complete successfully. This will be waiting for a task in another tag that is completed successfully or not. If not, then it will not be running. So again, this is the point to take care. Okay. While whenever you are setting up, then you have to set up for the task based, and you have to provide the details for the another tag which is dependent here, for which it should wait. And once that is completed, then this will run. So this is the import for the external task sensor. And then you have tag. Here you can create the tag, and once tag is created, then here wait for external task. Okay, and then it will be waiting for the external task. This is you have imported, then task ID, wait for external task, you can give any name. Then external tag ID, you have to give the tag ID of the external one for which it should wait. Then external tag ID source, then allowed state, either it should be in success or wait or whatever. Then poll interval, how frequently it should check either that job is success or not, and what is the timeout. So after that, it will not wait and it will take the further steps. Then further steps in the sense that will not run, that will start failing. Okay. Then HTTP server. Again, you have this API based HTTP server where you can wait for a specific HTTP response from a URL that it is already existing or not, it is happening or not. If not, then your job will be waiting for that. And if it is existing, then only your job will be, your trigger will run. Okay, so here with the tag, you can create the tag where you can give all the details as a tag, and then you can define here wait for tag, then HTTP sensor like file sensor and all, and then wait for HTTP response, then HTTP default, and then endpoint. What is the endpoint for which it should wait? Then response check. It should check the response, either status is success or not. If like here it is saying the response JSON and response JSON status equal to up, it is up or down or whatever. So if it is up, then it will run. If not, then it will fail. Then it can check every minute. So interval is 60. in seconds, and timeout is 18. That means 30 minutes. It will wait for 30 minutes. If it is not up, then if status is not up, then it will fail. Then along with file sensor, you have some SQL sensors as well. Then in SQL sensor, you have to import this SQL sensor, you have to import the DAG, and you have to take this net time. And then in a similar way as above, you have to create the DAG. And once DAG is created, then like file sensor, time sensor and all, you have to create SQL sensor, where you can provide all the details like SQL condition, SQL sensor, and then connection ID, let's say Postgre default, this default I have given, and SQL select count star from your table name where condition equal to true. It can be any query. Then check for every 30 seconds and timeout after 10 minutes. And if all match, then your job will run or else it will fail. Then key parameters common to sensor, poke interval, timeout, soft fail. So poke interval is frequency in seconds of check for the condition. Timeout, maximum time in second to wait before failing the task. It will wait. And then soft fail. Soft fail in the sense, if true, the sensor will mark the task as skipped instead of failing when it is timeout. So timeout means actually it doesn't fail because of any processing error or maybe some other error. It just failed because it did not meet the condition. So because of that, if true, sensor will mark the task skipped and it will not flag that as failing. Then here just I have made one example for additional example for run all the tasks parallel. Okay, so here just quickly go through this. Here you can see I have given task 1, task 2, task 3. These are running in parallel. So what is the things to note here? No dependencies, tasks are listed independently here. No, this symbol or this symbol. Operators are used to define the task, define the relationship. Then parallel execution setting. Ensure the following setting in your Airflow config and parallelism. Maximum number of tasks across the DAGs that can run in parallel. Default is often 32. And then DAG concurrency. Maximum number of tasks allowed to run in a parallel for a single DAG and default number is 16. Then worker concurrency. Maximum number of tasks a worker can handle simultaneously and verify resources. So the number of tasks that can actually run in parallel depends on available system resources with CPU, memory, and all. So these are some things to note. And then testing the DAG. Once everything is done, then place the script in the DAG directory in your Airflow home. Start the Airflow web server and scheduler and go to this port 8080 and go to Airflow scheduler and trigger the job and verify that. Okay. Here you can see Airflow DAGs trigger parallel task DAGs. Okay, so this will be working out for you and I hope that you have understanding about it now. Now let's come to Python code, how we are defining it. So here you can see this Airflow. I have just created a folder, test demo DAG, and inside this I have several classes which already I showed you about the document. So first I will start with the first demo DAG. Here if you see, just I am importing this DAG Python operator time delta and then let me delete it, unnecessary comment, and owner I am giving an Amica saying then retry 1, retry delay minute equal to 1. If you want to give some additional setups also, you are allowed to do that. Then with DAG, here I am creating the DAG. So this is my first DAG, you can give any name and default args. This is the default args. Then description, my first Airflow DAG. Schedule interval, I want to run this job on daily basis. And start date is 1st January 2024. Catch up false. That means catch up false means I don't want to take care if any missed job, missed schedule for the past dates. If that is so, it should not care and it should run for current date only. Okay. So what I want to run in this DAG, I have a function and this function I wanted to run. So this is my task one. Okay. And in this task one, I am calling this function print hello using this Python operator where you can provide a hello task and then task one. Just type it here and you are done. Your task one will be trigger and once this will trigger, then this will call out this function and whatever is defined inside the function, you will be getting as your output. That's it. So this is the very simple DAG. Then you have some complex one. Okay. So for that, I will go through the another one first and then go through parallel. Okay. So for parallel, everything is same. Now let's assume that I have three tasks. So I have a function task A, this is doing something. I have task B, this is again doing something. And similarly, I have task C, this is having its own task. Then I will create the DAG. DAG is the parallel DAG. Then it will run on daily basis. And this is the start date and catch up equal to false. Then I have to create a task for all three functions because I have three tasks A, B, C. So for each three, I am creating task one, then task two, and then task three. So task one, I am calling task A. This is my function call. Then again, this is my task B, and this is my task C. This is the function name. You can verify that this function name is same. Here it is highlighted, task C, right? Like that. Now, I wanted to run this in parallel with no dependency. I should run parallel because they are all independent. So in that case, just do it like this. That's it. So here, task A, task B, and task C will be running at the same time without any wait for each other or any other. It is not required. This is just going to run in parallel. Okay. Now let's say schedule interval. So for schedule interval, again, you are doing the import, then you are creating the DAG, and once DAG is done, then, okay, it is the different file. Let me go through parallel jobs and sequential jobs. Okay, so this is the sequential jobs. For the sequential jobs, first import, and once import is done, then default args like another classes. And then let's assume that I have some task like task A, task B, and task C, just like we had in parallel jobs. Okay, once it is done, then we need to create a tag. I created a tag with sequential tag, and schedule interval is daily, and then catch up equal to false, and then we'll create the tag for each three tag. I'm saying it's task. Okay, so create a tag for this naming sequential tag, tag ID. Using this, we will be good to monitor the job. And then creating the task for each of the function. So task one, which is calling task A, and then task two, which is calling task B, and task C, which is calling task C. Now you want to run in sequence. So in sequence, you are just giving this greater than symbol. That's it. So if you are giving greater than, then it will be running the job in sequence. And if you are giving comma, then this will be running the job in parallel. That's it. Otherwise, everything is completely same. Then here is example for sequential and parallel combination, where you have multiple tasks and some tasks are dependent, which will be running in sequence, and some tasks are not dependent over any. So that will be running independently, parallelly. So first import is done, then default tasks, then task A, task B, and task C. These are the three functions. And once these three functions is done, then creating the tag. Tag, I am giving defined tag, defining this tag name as combined tag, and then schedule interval is daily, and Finally, giving the start date when it is starting and catch up equal to false. So again, catch up equal to false. So if any job schedule is skipped or did not run because of any reason, it will not run for those stage. It will only running for current date because it is not caring for any missed schedule because it is set up as false. Okay, so now task 1. For it, we have three functions, task A, task B, task C, and for each one we will be having separate task 1, task 2, and task 3. And in each task, we are calling the function task A, calling task A in 1, task B calling in task 2, and task C calling in task 3. Again, you have task 4 and calling in task D. Okay. I have only 3 tasks here, so let me create one more. Because down I have mentioned that. So task D. And then task D completed. Fine. Now I have 4 tasks. And here I am calling task 4. So task 4, task D completed. But again, you see the differences. I had not given it above. Here task C I had given because task C was there. Task D, it was not there, just I created that. Then what was the purpose of it? I will just comment it. What this task D is doing? This is just printing task D completed, nothing else. So the function directly I am calling here. Callable function equal to, instead of task C, here could be task D. Instead of task D, I am just calling the function what I wanted to do. So lambda print task D completed. So even no need to define the function. Directly I can write the code here and this will be working. Now we are need to schedule in combination of parallel and sequential both. So see task 1 and then greater than. That means that is having dependency. The next job are dependent upon it. So first this job will run. Then task 2 and task 3 will run in parallel. These are comma separated, right? So these will run parallel. And once these both are completed, then task number 4 will be running out. Okay. Task number 4 means this, which will calling the day. Like that, it will be scheduling means you have to import, you have to go through the default terms, then you have to create the tag, and then for each of the task, you have to create the task and then call that. Then schedule it either with dependency or without dependency or combination of both. Okay. Then let's go with the next example, ETL tag. Okay. And for this ETL tag, here I have given the default works like owner, dependent on past, email on failure, email on retry and all, and then extract. So in extract, I am doing something, then in transform, again I am doing something, and then in load, again I am doing something. So I have 3 functions. Now to run this 3 function, I have created a tag. In that tag, I am naming this as ETL pipeline and default tag equal to default terms. And then description ETL example pipeline, schedule interval, time delta, and start date, date time, and catch up equal to false. Now let's create the task for each of the step. We have 3 steps, extract, transform, and load. So for each 3, we need 3 tasks. So creating extract task, okay, we are giving the task ID and Python callable extract function. Then again for the transform task, where task ID is transform and Python callable equal to transform. And then load task, where task ID equal to load and Python callable equal to load. So I created 3 functions, then I created a tag, and then I created 3 different tasks for each, and I called out all 3 functions inside this task. Now it's time to schedule the task. So giving with the dependency, first the extract task will run. Once it is done, then this will start, and once this is done, then this will start. So all are dependent. It is not running in parallel, it is running in sequence one by one, once after previous one is completed. Okay. So we are done with the parallel, then sequential and parallel combination, and then ETL diagram. Okay, next we will see three files like file sensor, and then time sensor, and then external task sensor. And then I will walk you through the real-time project we are working and how we are doing the monitoring and all. Okay. Okay. So now let's see the example for file sensor. If we have any job where a dependency is any file that after arrival of the file only job should run. So in that case, in the similar way, defining this default args, then go for the okay. So this is the file sensor tag, that was different file. So here in the similar way, taking all the input, then defining the args, and then creating the tag. Inside tag, here I have given the name file sensor example just for understanding and making it readable. Then calling out here default args, then date time, and the schedule is daily. Catch-up is false. Then wait for the file. Here file sensor, which is in the import here. We have imported it. So taking file sensor, task ID, wait for file. This is connection ID. The connection ID for the file system we have to provide. Okay. Then file path. What is the file and what is the file name? We have to provide the complete file path. So POC interval 60 every minute. So every minute it will go and it will check to the path if that file is available or not. Once this file arrives, then job will run. Otherwise, this will wait for timeout, whatever we have provided. So here 600 seconds, that means 60 minutes. So it will wait for 60 minutes, 10 minutes. And if file is not arriving in that time, their job will fail. Here mode is poke. So mode of the sensor, it can be rescheduled or it can be poke. Okay, so then defining a Python function to run after the other file is found. So let's say file is found. Then process file, and whatever you want to do, you can mention inside this function. Here I have not given the full code because let's say you are getting the file, then once file is arrived, then you have to do something with that file, like open the file, get the content. Let's say that is a CSV file, then it is having some columns. So for few of the columns, you want to do some transformation and you want to apply some logic, and finally you want to save that data to some other location. So that all you can do here. You can mention your logic and you can process it. So let's assume that this is your function where you are just giving the print file found, processing it now, and then you do whatever you want to do with your another additional functions, and then task after file, then process file. This is the function, and this function let's call it, and then wait for file. In schedule, first it will wait for file. It will track unless file is available, and once file is available, then this will run, this task will run. Okay, so this is the dependency. This is the dependency for the file sensor. Similarly, you have time sensor, where in the DAG all the things will be same. Here in the DAG I have given the name time sensor example, and here if you see, instead of file sensor, it is having time sensor, and same is in the import here. Okay, this is time sensor, and wait for a specific time. This is the name I have provided. Target time 12. Let's say you can give any time. So this will wait until noon. Before that, this will not process. It will not trigger the job. Okay, then pull interval 60 seconds. It will check every minute. Okay, and then it will be timeout after 10 minutes. Okay, once that is done, then a specific time reached. This is the function. where it is checking for the time and now processing. Similarly, here creating a task and then Python callable, I am calling this function and it will be having the dependency with wait for time. Once time is okay, then task for time, this task will run, this will trigger. So this is like a file sensor, then time sensor. Then I have some external task sensor. External task sensor in the sense, let's say you have another DAG, let's say this is the DAG and this is the DAG. You want to make sure that once this DAG has completed, then only this should trigger like that. So here I have imported external trigger and now given the default args and then DAG. So in this tag, I'm taking tag ID external task sensor example, and then schedule interval is daily. Then wait for task in another tag. So external task sensor, this will be waiting for the another tag. Okay. Then wait for task in another tag, other tag ID, whatever ID is there, you have to provide. I will walk you through with the real example. And external task ID you have to provide, then timeout, it will be waiting, it will be tracking, and then POC interval, it will be checking for the minutes. Okay, so it will be checking, it will be tracking for this POC interval, and then once this timeout, let me keep it at bottom. So this will be up and let me take it down. Okay. Okay. Now it is fine. So it is down now. It's fine now. Okay. So it will be checking for every minute and then timeout. Once timeout will be reaching this 600 minutes seconds. That means 10 minutes. Then it will be skipping means just soft fail. Okay. It will be timeout and then process external task. So once that external task is done, then only this task ID will be triggered. So here dependency is first it will be waiting for the task in another DAG. Once that task is done, then it will be running the current DAG. This task after the external task, this is the current uh, DAG task. Okay, so these are some examples like how you can schedule with the dependency, parallel, sequential, combining of sequential and parallel both, then time sensor, file sensor, external task sensor and all. Then I will share something schedule interval. This is just example how you we are providing the schedule time. So let's say this is the tag and you are providing the time schedule interval. So schedule interval, what are the formats you have? Once means run only once when trigger, then run once at midnight, schedule interval daily, then you have hourly if you want to run every hour, then running every Sunday at midnight, that means weekly. Monthly means run once in a month at the first at the midnight, then yearly means run once in a year and January 1st at midnight. Similarly, yearly and annually both will work same. Then cron expression like you can provide. Let's say you want to run every Monday at 3:30 a.m. Then 3 hour minute and then this is the first day, Monday, it will be running out. Then every day at 6 p.m. Then this is 6 p.m. Okay. Then 15th day of each month. Then like this you can provide the schedule interval. Then run every 30 minutes. Then you can do either like this time delta minutes equal to 30 or you can do like this. If you are providing this expression, then this will be running the job after each 30 minutes. Okay. Okay. Now no automatic schedule. Manual trigger only. If you have some DAGs and you do not want to run it automatically, you want to take it as a schedule interval. In that case, you can go for None. You can set it. Then cron expression again, schedule interval Monday to Friday, 7:30 a.m. 1 to 5. 1 to 5 means weekdays, Monday to Friday. Okay. And this will be running every weekday, Monday to Friday at 7:30 a.m. So this is hour, this is minute, like that. Again, you want to run on Monday, midnight, Monday to Friday. So 00 and 1 to 5. You want to run every weekend at midnight, then 6th and 7th. We have 7 days in week, right? 1, 2, 3, 4, 5, 6, 7. So 1 to 5, it is taking for weekdays, and 6 and 7th, it is taking for weekend. So this will be running for the weekend only. Again, if you want to run every Friday only, so 5th means Friday, 00, 0 hour, 0 minute, then it will be running over the midnight. Here, run twice a day. So you want to run 6 a.m. and 6 p.m. both. Then you can say 6 and 18. 18 means 6 p.m. evening. So it will be running every day without any other consideration. Everything is blank. Then run every 3 hours. Everything is blank, no any other input, only 3. So this will be running every 3 hours. Then run 3 times a day, 6 a.m., 12 p.m. and 6 p.m. Then you are providing the minute equal to 0 and hour 6, then 12 and then 18. It will be running accordingly. So you can see that how easy it is. You have to just provide the detail that when it should run and how it should run. Then field of order. If you see this, then what is the order of this field? First is minute, second is hour, third is day, then month, and then day of the week. Okay. In the cron expression, here, like let's say you are giving this slash 30. That means every 30 minutes, any hour, any day, any month, doesn't matter. Then 0 to 9, star 1 to 5. That means 9 a.m. Monday to Friday, 1 to 5. This is weekday. Okay, like that you can have the schedule, either you want at midnight at the first day of the every month, or midnight every Sunday, or 6 a.m. and 6 p.m. every day. You can schedule it, and here you can understand with this flow, like the last one, this is the day of the week, 0 to 6. Okay, then this is month 1 to 12th. Just give me 1 minute. Just I am checking something. Okay. Okay. So here this parameter is for day of the week, where you can say 0 to 6. And again in above, if you have seen, let me go through that. Here I have mentioned that 6 and 7 for weekend. Okay. Like you can go for every weekend, Saturday and Sunday. So here I am giving range for the 7, and here it is for the 0 to 6. So in Airflow, it supports both the range. Either you are giving 0 to 6 for 0 means a Sunday and 6 means a Saturday, or it supports 1 to 7, where 1 is Monday and 7 is Sunday. Okay. So 1 is Monday and 7 is Saturday. So it is supporting 1 to 7 and 0 to 6 also, where 0 will be Sunday and 6 will be Saturday. So Sunday to Saturday it will be supporting. So both are the expression is fine. Okay. Either you are starting from 0 to 6, that means Sunday to Saturday, or you are starting from 1 to 7, that means Monday to Sunday. Both is okay. And both ranges will be working here, because Airflow used the crontar library for parsing cron expression, which supports both ranges 0 to 6, that means Sunday to Saturday, or 1 to 7 means Monday to Sunday. So anything is fine as per your understanding. You can use any. And you can use 0 to 6 for a word ambiguity to stick with one format if multiple people are working parallelly with maybe same application or with multiple application and make it static with the format. So 0 to 6 is more common in cron usage where you can set up 0 and means you can set up 0 with Sunday and 6 for Saturday. So here this is for 0 to 6 day of the week. Second one is for month 1 to 12. Third one is the day of the month 1 to 31. And then this is for hour and very first one is for minute 0 to 59. So like that it is supporting. And for this example, where I have given 0, 9 and this schedule weekdays, where every weekday at 9 a.m. my job should run. So what is the format again? This last one is for day of the week, Monday to Friday. Then this is for month 1 to 12. This is for day of the month. And this 9 is for hour, 9 a.m. And this 0 is for minute. That means 0 minute. So like that you can give the scheduled time. Now I am coming to the real work. Okay, so this is the real project. Okay, so let's assume that I have developed some code. Let me go through that. And inside module, I have utilities. And inside utilities, let's assume that I have developed one code. This is the query book code, okay? Where I am reading the data, I am doing lots of transformation and multiple things are there. And once it is done, then I am looking for schedule. So this is my final function, okay? This function is calling my write query book data to Colibra. This is the last one. And I need to schedule this job which will be running on a interval. Then how I will schedule it. So this is my Python class, Python code where I have developed, I have did all the transformation and all, and finally it needs to schedule. So you have two approaches, either directly create the DAG file and call this function directly, or create an intermediate file where you call this file, call this function, and then that app file you call in your DAG. So for this approach, I have created the app file as intermediate file, and that app file I have called into the DAG. Okay, so this is my main class file, Python class file, where this is my main function, which will do the entire processing. And now you can remember the name query book. Class is query book integration to Colibra. Now I have one app folder. Inside this app folder, I have that intermediate file. Here query book integration. Okay. Here what I am doing, I'm not doing anything. I'm just taking the necessary import. Then I am calling that class. And from that class, I am taking this query book to Colibra integration, and then I am taking this function, main function, which was in my Python class. Okay, and then environment variable, because if you see this is parameterized, I need an environment variable for which environment I want to run. So in this app file itself, I am providing prod dev test, or maybe you can make it configurable this also instead of providing the hardcode value. But for now, this is hardcode value. So I am not doing anything. I just created a class, app class, where in this app file, I am calling my function which will be completing the processing. This is the complete code reference. Okay, now I am going to DAG file. Here I have a DAG folder. Okay, inside this DAG folder, I have the DAG for this. So let me maximize this. So this is the query book integration DAG. Let me go to the DAG. What I have did here. So this is my DAG. I have imported this, then region, then this data compute is Spark operator, then Airflow variable, whatever required, I did the import. Then Default talks, I'm saying data engineering core, then depends on the past, false. Then start date, I'm taking as per a requirement you can take. And then email, I want to send the email to this email ID. Then email and failure, either you want to make it yes, true or false. If you want to get the email, then you can make it true. Email and retry false, and retry 0. Catch up false. Here also, as we discussed, for catch up, if we want to take care for the missed schedule or not, if I have done true, then it will run, and if I am making false, it will not run. It will run for current date only. So I don't want for the previous dates, if any missed as well. Means in a missing condition also, I want to run for the current date only. So I have make it false. Okay. Then DAG, I created the DAG. In the DAG, I am giving the DAG ID. So using this DAG ID, I will be good to monitor my job. With this will be the reference. Okay. Now default args. I am passing this default args. Then catch up false. Again, this is duplicate, not required. And schedule interval. This is 12. Minute is 0. Hour is 12, 14. Okay. So here you can see for schedule interval in this parameter, first is 0, 0 means minute. Minute is 0 minute. This is 14. 14 means 2 p.m. And then these are nothing. And 1 to 5 means Monday to Friday, weekdays. Okay. So this will be running Monday to Friday every 2 p.m. afternoon. Only one time. Okay. So this will be running like that. Then how my DAG will get the jar? Means we want to run a code, right? Code base. So that code I am pushing to my GitHub. And that GitHub is integrated with the Docker. That as soon as I am pushing the code with the latest commit, Docker is building the image. And once it is means it is creating the image for all the latest commit, and it is pushing that image to the configured location, and from there it is getting deployed to Kubernetes, and then Airflow will be running this image file in the Kubernetes pods. Okay, so this is for that I am giving the environment, and then task name for the query book. I am giving this task name. Image path. This is for my Docker image. Okay. Docker images, as I said, we are doing the development, then we are pushing the code to our repository, and that repository is integrated with the Docker and all. Then it is creating the image for each latest commit, and that image is getting pushed to the location, configured location, and using that, this is getting deployed to the Kubernetes pods, and from there, this Airflow is good to run that. Okay. Now, I'm saying if environment is prod, then image path will be this. Take the image path from this one. Okay. Then I am creating this task. As we discussed, we need to create the task. Once you are creating default args, then you are creating a DAG, then finally I'm giving the image path from where it should take that, and then this task. Inside task, what I am providing task ID, then app name, then anyways, these are, this is completely not required. Okay. This is also not required, you can skip. Task ID is enough. And then vault enabled. Here we are managing all the credentials using auth and vault. So that is required. Otherwise, this will not be able to get the credentials to access the required repositories and all. So it is enabled, true. If you are doing the POC in local, then your local credentials will be working out. Then app arguments. As I said you that directly I am not calling my query book a class file. I have created one app file, and inside that app file, I have called my function. This is the app file, and inside this app file, I have called this. So here in DAG, I will call this app file. So this app file will be calling this function. Okay. So I called that app file. This is the app file name, app.app file in app arguments. Then artifact path. Again, this is our artifact path. Then compute platform. These are the optional. This is as per project wise. Okay. And then Docker image. Docker image, what it should take? It is taking the Docker image above path is defined. Okay, this path. And then job count, timeout in seconds. This is 9,000. Then DAG. This is taking the DAG. That's it. It's done. Now I am calling this task here. Trigger the task. This is the task. I just called down. That's it. My task is good to run at 2 p.m. every day in weekdays, Monday to Friday. I am done with it. What I had the main class, then I had one app file just as an intermediate file, and then I called that app file into my DAG. And there is no dependency. This is a single trigger. Okay. Now I will walk you through the another example. Where in another example, okay, let me go through this DAG itself. Again, okay, I will walk you through one more, and that is, let's say, this Jira. So for this Jira, I have again some functions, lots of functions are there. And finally, I am, this is my final function, okay, which should run. Anyway, there is no parameter. Fine. So this one. Now, I am going to call this function to app file. Again, you can see inside app folder, I have one this app file where I am calling this utility to process Jira issue to DMAR table. Now I will be calling this function inside the DAG. This is the DAG, and inside this DAG, I am calling this same. Everything will be same as it was in the previous. Here even I am giving the email where if any failure or something, if I am making it true, email and failure true. So if any failure happens, email will be sent to this two email ID. Okay. And then finally, I am giving this I am calling that app file here. And then I am calling this task here. Okay. So now let's come to the UI. And first I will walk you through this. Then I will be going through the dependency. Let's go to this UI. Okay, so this is just the UI for the tag. I will go to the code base and I will copy the DAG name so I can track it. So my DAG name is this Jira dashboard. This is the name. I will just copy it, DAG ID, and will come to the UI and search here, search DAGs. So if I paste it here, I can see this DAG. So here you have multiple options. You have DAGs, you have cluster activity. If you click here, and then you have data sets, you have security, you have browse, diagrams, jobs, audit logs, task instances, task reschedule, triggers. Multiple options are there. You can go through it. Okay. So this is the cluster activity, unused, passed DAGs, that is 22, and the metadata database, that is healthy, scheduler healthy, trigger healthy. Okay. And like this, it is having diagram states, diagram types, and task instance as states. All the things are here. Okay. Now we'll come to DAG. And from this DAG, we can monitor. So these are all the running DAGs. Means these are schedules where 22 are active, 5 are passed, and 0 running, failed 8. Okay. Let's search the Jira one. And see, this is the board for it where you can go for the graph, calendar, task series, and all. Here you see schedule 30 minutes every 30 minutes as we see in the DAG. If you come to DAG, let me come here. See, here it is the schedule interval, right? Every 30 minutes. So here also you can see it is saying every 30 minutes. Next run when will happen? It will be UTC, okay? 10. So 10:30 UTC. So always by default it is UTC time format only, time is time. Now these are the states: default, failed, queued, removed, restarting, running. You will be understanding with that. So all these are run. Let's say it will be running automatically once the time is done for every 30 minutes. But let's say that I want to run it. Then what I can do? I will just trigger the tag. Okay, manually. So this is manual trigger. Otherwise, with the schedule, automatically this will run. So once I clicked on the trigger, then see this is green, and here you can see running state. It is running. Okay. Again, if you are in the DAG, here also you can see this. Let me search from here. I will again search that Jira, and I will go here. Jira dashboard, this one. So this is running green. Okay. So I will click here. And then you can see this is in running state. This is the tag ID. This is the logical. I have run manual. Okay. It is not running with the schedule. So let me click here in the tag. And once I am here, again, it will be coming to the same page. Now, this is the green, and it is saying that this is in running state. Okay, so here you can see in the code exactly will be getting the same code we have provided in the tag. Then you have this option, you can see the status. Then you have graph, you can go to the graph. This will be telling all the status of running and all. Then you have details where it will be giving all the details, either it is running, scheduled, or whatever. Then we want to go through the log. You can click here, okay? I will just clicking. Then here you can see log, log is there. Then let me click here. Once I click here, then I can go to, this is the log. So let me click on see more. If I will do see more, then I will be getting to the page. And here I will be getting the log. So this log will be, here I will be getting the Kubernetes log where it is deployed. Okay, so this is the log. Let me click here. And this will be walk me to the Kubernetes dashboard. Let's skip. And then these are the pods. Okay. So inside these pods, you can see multiple options are there: cron jobs, demonstrates, deployments, jobs, pods, and all. So here for the log, I need pod only. I am here because I click directly over the link. Now here I have view logs. So I am coming to view logs. And here you can see this is the log. So now I can go down and you can see whatever is happening, I can see here. Okay. This took number of records updated 913, number of records inserted 0, number of records deleted 11, like that. I got it. And now I want to do, so if here I can monitor the log, and if I want to download it for further analysis or want to track something, then you can download it. How you can download it? You just come here and you will be getting one option here, this arrow. So you can just download. I can download it and save it. So this is downloaded. Okay, it's done. Like that, we can do the monitoring. We can go through the logs and we can check the logs and all. Okay, so this was for one of the jobs. See, now job has been completed and it's a success. It's green. Okay, done. Now coming to another file. Come to Airflow, and here I have query book. So query book also, for query book also, it is a similar tag. So I can check it like that. Just let me search this tag over the portal. So here, let me do Control F. Sorry, here I will not be getting. Let me do tag. And in this DAG, I will be searching here DAG name. So if I do this DAG name, then I will be getting the details of the job. And again, if I want to run this, see if this is having two failure and then success. So if I want to run this, I can. Okay. And if I want to run again, I can trigger, but I will not run it. So this is also same like Jira one. This is not having any dependency, because if you will go to graph, inside graph, there is only single job. There is no dependency. If dependency, then you will be having multiple here. Okay. Now I am coming to next. So let me come to the Airflow. This ingest data from sources. So here you can see that I have multiple jobs here. Here, first I am creating the default args, then creating the tag. This is the tag ID. Let me copy this. So we will track the job with this. And then task name. I have 5 tasks. DB Insights, then DB Insights Sandbox, then Query Book, then Datadog, then CGF. And all 5 are running with a different dependency. So all the code is exactly same like others. Here is the image path, then creating tasks. I am creating 5 different tasks, okay, for each 5. And here you can see app option, Spark some app option also you can provide. Here I am providing some Spark configuration and Spark related jar, that is Postgres jar, that is required for our Spark job. So I am providing here, you can provide that. And then calling the app file for this, okay, required app file. Similarly, I am doing the same for all five tasks. Okay, all 5 tasks are created, then calling this. So first this 2 tasks is dependent upon each. First this will run, then this will run. And next 3. These are like first this will run, then this will run, and then this will run. Okay. Now come and see this DAG. So this is the same DAG for the source file. Okay. And this is scheduled for this is running here. You can see run ID and the schedule time. This is getting filled as status. You can see first this is there are 5 tasks: ingest DB Insight, Sandbox, Query Book, Datadog tables, CGF tables, and all. And see the graph here. Just click on graph, so you will get it. And while clicking on the graph, you can see it here. So see, first this is running, then this is running. They are success. Then this will run. And once this is complete, then this will run, and then this will run. Here you can see upstream failed. Why? Because they are running once this is done. But this is only failed. If this is failed, then they will not run, and this will also not run. So like that, this is running and this is scheduled. Okay. Now I will go through another diagram. That is this import reference. Okay, here I am not creating any app file. Okay, directly I am calling the function. So I want to call the class, this class, this class, this class, and this class. Four Python classes are there. I need to call that. So I just created the default args. Then this is the DAG and this is the DAG name. So I will copy this DAG name to track the job, and then I am directly calling. As I do not have the app file, so directly I am creating 4 function for all 4, and inside this 4 function I am calling this function related to the class. If I will click on any, let's say this is my main class. Okay, utility import reference set and environment is prod. So let me come to the DAG file again. Import reference DAG. Yeah. So here I am directly calling this. I do not have any app file as intermediate file. Directly I created my DAG and then I am calling the classes which I want to schedule, which main function. Okay, so for all 4 classes I did this. I call all the 4 functions. Okay, now I provided environment as well. That is done. Then Here I am creating DAG for all four with DAG, Python operator, task ID. This is the task ID, Python callable. That means what? This means this function. Okay. Then this function is for second one. You can see this highlighted. So this is for the second one. Then this is for the third one. And this DAG is for fourth one. You can see this is highlighted. So like that, first called all that four functions, then created DAG for all four and call that function, and then finally scheduled. So this is dependent, then this, all are running one after another. Okay, all are dependent, running in sequence. So you can see without application app file is not required. App file I had created in another one just to make as a reference or intermediate file you can say, or else directly in the DAG you can call your Python class directly, and then for each you can create the DAG, and each DAG you can call it here. So this is the first one, this one, then I will call this one, then I will call this one, and then finally this one. Okay. See, this is highlighted, you can see. So like that, without app file, I have did it. Now I have another, this is the landing. Okay, so let's talk about this Spark landing DAG now. Along with this DAG, I will talk about this Spark processing DAG also. Why together? Because they are dependent to each other. We had discussed about sensor, right? So here we can see the example of external task sensor. That means first this landing diagrams and this load the data from the source. And once data is available, then this processing diagrams and process the same data which was ingested with this DAG. Okay, so now let's come to this DAG and we'll walk you through. So similarly, we have given this default args, okay, and then similarly, this is the DAG where this is the DAG name, DAG ID. Using this we can track. So let me copy this, and then here you can see the environment, and then three tasks are there. Task name AMS, then events, and then click stem. So three tasks are running with this DAG. Okay. Then we have image path. Image path, you already understand that this is the Docker image, which is by our repository, what the code we are pushing to the repo. Okay. And this part is for if we want to trigger this job with our feature branch and not the latest master branch, latest commit. So if we want to go with the feature branch, we can give this. Anyways, you can explore this. Right now we are not talking about that. And here it is getting the image path from the latest build from our repo. Okay, then you can see task start, and then we have task created for AMS task 1. And here you can see some options like app option. This is the Spark job. So we need some configuration for Spark and we can provide here. So I have provided. And one Postgre jar is also required as a dependency. So that also provided here. You can provide it. And then app file. You can see app file is provided. And next, similarly, have created the task for clickstream task and then for the event. Okay. So all are same only name is different. So all three tasks created and one start task created and one end task created. You can see one more time. This is start task start, and then we have one end task. Okay, end task end. So first we are starting with this start task, then we are running all these three, and then finally we are calling task end. So that's it. We have three tasks that is running with task start, ending to task end, and in between we have three jobs to run. And once this will be completed, then only this processing DAG will be running. So processing DAG is looking out for this DAG to be completed using sensor, and once that is done, then only it is triggering the job. Okay, so let's see first this DAG. Let me search it. So if you see the DAG. This is having first start and end like we see in the DAG file, and then this task is running, then this task is running, and then this task. All are running. Now see the graph. Once coming to the graph, how it is scheduled, then you can see here, see, first start, and once it is starting, then it is running with the, running all the tasks, okay? And then finally, once all is done, then it is calling the end task and it is done, okay? Like that, this is running, okay? So this is done. Now going to next tag. So now come to the Spark processing tag. This tag is having dependency with landing tag because first this loads the data from source and then only this will be processing the same data. Okay, so if you look out here, same with the required import, then default terms, whatever is required, you can give it, and then coming to the tag. So this is the tag ID. I will just copy it for monitoring. Okay, and now as you see, here we are processing 5 tasks, 5 different tasks, means code base. So task name, AMS, then click stream, event, feature, and model. Differents are there. Okay, now this is image path. You already understand. This is for our latest code build. Okay, whatever we have pushed to our repository. And then this is the tag task sensor. This is the difference with another tags, whatever we already seen. This was not in any of the tag. Okay, so this is external task sensor. We had discussed about it already. So this processing tag will be waiting for this landing tag to be complete, then only this will start. So this will be complete. This will be waiting for wait for landing tag completion, and this is waiting for which? Then this is waiting for Spark landing. Where is Spark landing? This is Spark landing. Okay. So first this will be done, then this will be trigger. So this will be waiting for this DAG ID, and this is the task ID we can see when we are monitoring. Then external task ID, then mode, all the configuration which is required given here, and then task start. It will be starting the task. And then for all the tasks, you can see that 5 tasks has been created for all different 5 code bases. Okay. So it is completely similar. There is no differences from previous one. If you see, we have given task name, then task ID, app name, then vault enabled, app option, if any configuration is required, then app arguments, you can see app file reference I am giving, and then another details. That's it. So what is the difference here? Difference is this external task sensor, which was not part of any because they did not had any dependency, but this has the dependency on landing. So we are keeping this. Okay, and with this, we are monitoring this DAG, either that is completed or not. Once this is completed, then this will start from the task start, then it will trigger all 5 tasks, and then it will end. So see, first how it is starting. Before task start, it is first calling out this DAG task sensor. Where is the DAG task sensor? This is the DAG task sensor, okay? And first it will monitor if that DAG has been completed or not. So first this is there, it will run. Once it is success, then only this task will start, otherwise task will not start, task will fail. So first this will start, then task start will happen, then all the 5 will run. So this 2 is running all together, and then this 3 is running all together. Okay, one by one. So first this is running, then this is running, then this 2 is running at once, means all together, and then these are running with the dependency, then this will run, then once this is completed, then this will run, and this is completed, then this will run, like that. Okay, so let's come to the UI and see this, how it is. So coming here, and let me paste it here and search. Okay, so this one. Anyway, this job it seems to be failing. Okay, no issue. This is a wait for landing DAG completion. Okay, and where is this? So come to the code. You can see this is DAG task sensor. Come here. You can see this is DAG task sensor and this is waiting for the landing DAG completion. This is here. This is what we were see. Okay. Now come again here and you can see this is there. Now we have start. So coming to the start and here you can see start, come to the code and you will be getting it here. We have task start, right? And then just after this, we have called out this task start. That is what we are seeing. And then, okay, let me go here. Here you can see start and this is what you are good to see here. Start and then our all 5 jobs. Okay, then come here and see all 5 tasks are defined here. This 2 is together and then remaining 3 are running one after another. Once these 2 completed. Okay. So let's come here again and see the graph, how it is. So if you see this graph, let's see. This is wait for landing DAG completion. So see, this wait for landing DAG completion is failed. And if this is failed, then none of this is going to run because they are dependent. You can see start upstream failed. This did not run because of fail. Same for this as well. This also did not run upstream failed. This is also same. And this event, this is also same. And this last one is also same condition. None of this is running because of this landing DAG completion is getting failed. It is not getting that. Okay, so if you see the schedule as per our code base, here you can see first we had called this DAG task sensor, then task start, and then all 5 jobs. First do this run, and once this 2 done, then all 3 will be in sequence. So see, first this DAG completion, then this start, and then this 2 is running, okay? And once this 2 is done, then this event is getting started, then this model is processing, and then this feature is processing. So if this could have success, then all running in the same sequence, whatever is scheduled using our DAG. But this itself gets failed, then it can't get proceed, right? So this is the condition. And like this, we can track all the things. We can monitor the DAGs. We can see either this is success, failure, or what is the reason for failing of the job. Or if that is success, then if we want to monitor the job, then we can monitor. Like I showed you already, that you can go to any of the DAG and then you can access the log from here. Like this is a Kubernetes one where you can go to the pods and you can do that. And I already showed you the log for one Jira code base. So you can again go to that and you can see how we are good to access the logs and all, monitoring and all. Fine then. So this is about the Airflow, how we can create the tags and schedule the jobs with dependency, without dependency, in parallel, in sequence, even with the sensors and all. Okay, so I hope that it was helpful to you and we gone through multiple examples. So I believe that that will be helping you for your future projects. And similarly, you can also create the tags and schedule the tasks with the requirement and as per the use cases, you can use different sensors and different kind of schedulers with either parallel sequence or combining with both the option. Okay, so this is all about the Airflow, and if you have any other question or any other points to be discussed, just let me know. We can discuss about that. and just try out this, do the practice and see how it is working, and I hope that it will be working fine and you will be good to do it. Okay, so next we will be back with some another informative session, and by that time let's have a break. Good day, bye.